Okay, here we are in the differential section. We're going to call this example 2A. We're only going to do one of them here, and then we'll do 2B on a different one, 2B, or not. I don't know. I had to do it. Okay, so the linear approximation. Use a linear approximation to estimate this value. So the foundation of this is that thing that we built in the introduction that I've written at the top of the board, all right? So I have that at the top of the board. This is a flashback to that introduction, all right? And so if we want to determine the fourth root of 16.8, here's the deal, and I wish I could have that picture up here too, but there's just not enough space, so look at that picture. I don't know if it's going to help. Anyway, you can take the fourth root of 16 in your head. 2 times 2 times 2 times 2 is 16. The fourth root of 16 you can do in your head. So the point is, we're splitting that 16.8 up into 16 plus 0.8 because we can take the fourth root of 16 in our head. So what's happening here is we're calling this 16 plus 0.8. So the point is that'll be the x plus delta x mentioned here. All right? Now as far as what's the function? The function is the operation being applied to this. So in this case, the function would be the fact that we're taking the fourth root of a number, all right? So we've identified our x and our delta x. We want the 16 to be the number we can put in that function easily, right? As mentioned earlier, you can take the fourth root of 16 in your head, and then the delta x, the 0.8, will be the leftover. So if we follow this particular pattern here, where we say, all right, I want to find f of 16 plus 0.8, then that'll be approximately equal to f of 16, fourth root of 16, you can do that in your head, plus f prime of 16 multiplied with the 0.8. Let's keep in mind, this is multiplication in that thing. So, times the 0.8. All right, so it's just kind of plug and play. You want the x to be the number that you can apply the function to easily, and then the 0.8 is the leftover, the delta x, if you will. All right, now before we continue though, part of this requires the derivative. So let's determine that down here. Well, in order to find the derivative of the fourth root of x, we'll need to change that into x to the 1/4 power, no derivative yet, just a rewrite. And then f prime of x, according to the power rule, would be 1/4 x to the negative 3/4, which in turn becomes, because of the negative exponent, let's put that underneath, 1/4 times x to the 3/4 power. That's our derivative, okay? So, now it's just a matter of sticking these numbers into the function as well as the derivative of that function. So, f of 16 would be that fourth root of 16 I've been mentioning. You can do that in your head. F prime of 16, I should probably change this back to a radical, but I don't feel like it. 1/4 times 16 to the 3/4 power times 0.8. And guess what? Now it's all just arithmetic. So as mentioned earlier, the fourth root of 16 is 2. So you can do that in your head. You always want that x to be a number. And I picked a number that was close to 16 for that reason. All right. And then, all right, 16 to 3/4 power, use your calculator, do whatever you got to do here. But I believe this expression on the bottom, 16 to the 3/4 power is 8. And 8 times 4 is 32. So that's 1/32 times 0.8. This is all just arithmetic at this point. So we'll take that 0.8 divided by 32 basically. And that's 0.025. And then I don't need a calculator. That's about 2.025. Okay? And that was using linear approximation. Now, if you wanted to cheat and kind of see if that seems like a reasonable answer, couldn't you put 16.8 to the 1/4 power in your calculator? All right, 16.8 raised to the parentheses 1/4 power And that would be the more exact value. That's beside the point. This is kind of going after the fact and cheating here. But just, you know, don't tell anybody. Don't tell anybody. I put that in my calculator to see if that's a reasonable answer. My calculator gave me 2.0245, blah, blah, blah. It goes off the screen. And look, it's pretty close, isn't it? Okay? But let's remember the reason it's off, the reason this is off, is because we basically, look back at that picture, we jumped from the exact curve to the tangent line when we put the derivative into the discussion. So that's why it's off a little bit. But that's a way you kind of cheat and see if it seems reasonable. Anyway, that's that one, and we'll come back and do 2B here in a minute. Or not.